This is a lesson on types and characteristics of bonds. There are 4 types of bonds in general. An ionic bond is produced between a metal and a non-metal. When these bonds form, electrons are transferred from one to another. The metal atom loses an electron and forms a cation. The non-metal ion gains an electron, forming an anion. If you were to diagram that, the electron would be transferred from one to another. The reason this occurs is primarily an energy consideration. Chemical reactions occur because you end up with a lower energy. One reason for the lower energy with a ionic bond is a stable octet. Stable octet means there are 8 electrons in the outer shell. If you remember S2P6, 2 plus a 6 makes 8 outer shell electrons, or sometimes they're called valence electrons. This is energetically stable because every orbital has exactly 2 electrons in it, and the motion is perfectly stable. The analogy I use is a washing machine. If a washing machine is lopsided, has more clothes on one side than the other, then it does not spin very well, and it wobbles and makes noise. If the washing machine in the spin cycle is perfectly balanced, then it spins very easily. The other way of explaining the energy considerations for why bonds form would be ionization energy. And electron affinity. Metals tend to have electrons farther away from the nucleus. They have 1 or 2 electrons far away, so it's easy to lose those electrons because they're far away. So they have a very low ionization energy. Which means it does not take a lot of energy to put in to remove it. And electron affinity if you have a non-metal, they have a very high or large electron affinity, which means there's a large amount of energy produced when you add an electron. So it takes very little energy to remove an electron from a metal, and you get a lot of energy to when you add an electron to a nonmetal. So between the two, any process that proceeds spontaneously or easily in nature, you end up with less energy. A rock rolling down the hill has less energy at the bottom, so that's why rocks roll down the hill. Another type of bond is a covalent bond. Covalent bonds are in two types, but generally what they have is when electrons are shared by two atoms. Electrons must be shared by two atoms to obtain your stable octet. So that is occurring when you have two nonmetals. If you have two nonmetals, they will share electrons in order to obtain 8 in the outer shell. Now there are two types, as I mentioned, covalent compounds. There are non-polar covalent. NPC is non-polar covalent. Non-polar covalent, the electrons are shared equally. Each atom gets the electron half the time. And then you have polar covalent. Which means the electrons are not shared equally. And we'll talk more later on why they are not shared equally, but let's say that the electron spends more time around one of the two atoms than the other. So, ionic, covalent, the last one is metallic. And a metallic bond is formed between two metals. Two metal atoms are the same. It can be different elements or the same element, doesn't matter. And here, the electrons are shared by all the atoms. The electrons are able to move throughout the substance. They're not located around one atom or a pair of atoms. They can move wherever they go. In that case, the atoms are not rigid. Rigid. Up here with the ionic compound, they're joined because there's a positive and negative charge between them. And those positive and negative charges are very, very strong, and they tightly hold them together so that the positive and the negative ions are stuck. They can't move anywhere. They're locked into place. In a metallic, you have the positive insides with electrons around the outside, and there's some give or take. The electron, the inside of the atoms can move around a little bit, creating the things that it can be malleable, flexible, things like that. If you take a piece of chalk and you try to bend it, it breaks. Chalk is an ionic compound. If you take a piece of metal, say wire, and you bend it, it will flex or bend. These are the types of bonds. Now we're going to talk about the characteristics of bonds. There are three of them that we're going to talk about: melting point and boiling point. And these are general approximations. There are many exceptions to the rule. These show you general trends. MP is melting point, the temperature that the substance will melt. BP is the boiling point, the temperature that they will boil. In general, ionic compounds have the highest melting points and boiling points, followed by a combination of metallic and polar covalent. They intertwine. There's not really a general trend. Some metallic and some polar covalent are different. And generally on the very lowest end are the non-polar covalent. Ionic, if you want to think about ionic, think about salt and the characteristics. Salt is a very characteristic ionic compound. If you take some salt, try to throw it in a pan on the stove, it will not melt. Metallic, think aluminum, foil. You have lots of examples of that. Some metallic substances will melt at a very high temperature. Titanium is used in high-speed aircraft because it can withstand very high temperatures in the engines and such. And then you have things like mercury, which are already liquid at room temperature. So there's a wide range of metallic. Polar covalent, you can think of sugar. You can melt sugar, put it in the stove, and you get caramel if you melt sugar down. Another polar covalent compound that you're familiar with is water. Obviously, sugar will melt on top of the stove. It'll get pretty hot. Water melts at 32 degrees. So there, again, is a wide range of temperatures for that. And there are some metals that will melt somewhere between water and sugar. So they're all intertwined in there. Non-polar covalent generally are the least likely to do that. Oil, propane are two examples. Many non-polar covalent compounds are gases. Oil, like cooking oil or gasoline would be liquids at that temperature. So whenever you think about melting point, boiling point, think about salt and how it would react. Aluminum or mercury or some other compound. Sugar for polar covalent, and cooking oil for non-polar covalent. So these are ways of idealizing what they are doing. The other thing is solubility in water. If you think about salt, aluminum, sugar, and oil, which one of those will dissolve in water? Well, salt dissolves, so ionic. Aluminum does not, sugar does, so that's polar covalent. These tend to dissolve in water. They don't always, there are exceptions, lots and lots of exceptions. Ionic example of that is calcium carbonate, which is chalk, which is seashells. Seashells obviously don't dissolve in water, so there's an exception there. salt does. So more things will dissolve if it's ionic. Polar covalent, same deal. There are some exceptions, but generally they tend to dissolve in water if it happens. And then metals and non-polar covalent don't dissolve in water. Metal ships don't dissolve in water when you put it in there. Some metals react with water, but they don't melt water. Non-polar covalent, oil and water don't mix. They float. Combination there. And the last property we're going to talk about is electricity, or electrical conductivity. In order for electricity to conduct, you must have either ions or electrons that can move. You have to have mobile or moving electrons, and you have to have mobile or moving ions. The things that do conduct electricity, metals, obviously because they have mobile electrons. That's one of the definitions of a metallic bond up here. You have electrons that are shared by all, they can move around. So all metals will conduct electricity, and melted or dissolved ionic compounds. They have ions, but they have to be able to be moving. So if you melt them, the ions can move. If it's dissolved, the ions can move. Things that don't conduct electricity are solid ionic compounds. Are the only ones that the only type of ionic compound that will not conduct electricity are solid, and any covalent, polar covalent or non-polar covalent. So metals and melted or dissolved ionic compounds do conduct electricity. Solid ionic compounds and covalent compounds do not conduct electricity. That ends this lesson on types and characteristics of bonds.